gotta love like whoa. Girls gotta love like whoa. I kinda feel like it don't make sense, cause you're bringing me in and now you're kicking me out again. What's wrong?
Hey, what you doing? Oh, I'm trying to figure out how short of the ladder to use to get my ball on the wall, because I accidentally kicked it up there.
Stupid. Just use calculus.
Ew, calculus is hard.
What are you talking about? It's easy. Watch, I'll show you.
Here, we can do our calculus work on this.
So here's what our situation looks like on paper. Here is the wall, which we will call Y. This is from U to the wall, and we'll call that X. And here's U. Yay! And then this is U, the distance of the ladder from U to the wall, and we'll call that L. However, you realize there's a tree branch standing in your way, which is right here. This is the height of the tree branch, which you discover was 5 feet. The wall and the tree branch are exactly 2 feet away from each other. So you'll put that as 2 feet. So that means from you to the tree branch, you're x minus 2. And when you add them together, you get x. So now it's your job to figure out what the total length you need for the ladder, but keep it as like the shortest amount possible, which then you realize this is actually a maximizing and minimizing problem. So you see this diagram looks like a triangle, so one equation you're going to use is the Pythagorean theorem, which is x squared plus y squared equals L squared. And when you simplify that, it will be square root of x squared plus y squared equals L. That would be the total length. However, you also need to find out the length of x and y. So that means you should set up a proportion. So here's how you do it. First you do y over x. Here you realize that y and 5 are both coordinating to each other. So that means y will be proportional to 5. And when you see this, you notice there are 2 triangles. This is one huge triangle, and this is the second triangle, which is proportional to each other. So when you see this, y coordinates to 5, and then according to that triangle, x would coordinate to x minus 2. Now here you're trying to substitute y in terms of x. So what you would do is bring x to the other side. And when you do that, you multiply them on both sides, and you get y equals 5x over x minus 2.
Okay, in order to find L, we need to have just one variable in this equation. So what we do is we take this number and substitute it in for y. And now you simplify that to become x squared plus 25x squared over x minus 2 squared equals L. Now to find the length of the ladder, the shortest length of the ladder, we have to find the point when the ladder changes from too short to too large. And that would be when the derivative of L equals 0. So what we have to do is we have to take the derivative of this equation. So derivative of L equals 1/2 x squared plus 25x squared over x minus 2 squared, all to the negative 1/2 times, go down here, 2x plus 50x times x minus 2 squared minus 25x squared times 2x minus 2 all over x minus 2 to the 4th. Now, this is too complicated to solve by hand, so what we do is we're going to use the equation solver on our calculator. Okay, and that all comes out to x equals 5.68. 68. That isn't the length of the ladder, that's the value of x, so we still need to do a little bit more calculating. So let's use one of our original equations to figure out y. So we know y equals 5 of x, which is 5.68, all over x, 5.68, minus 2. So y equals 7.72. And now we use our other equation, square root of x, which is 5.68 squared, plus y, which is 7.72 squared, equals L. And after all that, we finally know L equals
9.58 feet.
Whoa, now I actually understood it. Now I know what length of a ladder to use to get my ball. Where did it go? Oh, I must have fell over the wall.